March 14, 1943, North Atlantic, 200 nautical miles southwest of Iceland. Kapitan Lieutenant Werner Henke stands in the control room of U-515, watching his depth gauge tick past 100 meters when he hears something impossible. Not the metallic pinging of Allied sonar. He's learned to live with that sound over 18 months of war patrols. Not the distant thud of depth charges exploding at preset depths, giving him precious seconds to maneuver between patterns. This is different. A series of rapid splashes overhead, maybe 20 or 30 distinct impacts on the surface in the span of 3 heartbeats, followed by silence. Then the forward compartment disintegrates. The explosion doesn't sound like a depth charge detonating 50 feet away, it's pressure wave radiating outward in a sphere. This is a direct hit, metal against metal. 35 pounds of Torpex explosive making contact with U-515's pressure hull and converting the forward torpedo room into a blast furnace in 1/10 of a second. Henke's last conscious thought, recorded nowhere because he doesn't survive to record it, is that the weapon gave no warning, no time to dive deeper, alter course, or rig for silent running. The British destroyer above him fired something that travelled through water, found his submarine, and killed on contact. In naval warfare terms, that should be impossible. Depth charges explode at predetermined depths, whether they hit anything or not. Torpedoes are for surface ships, not submerged submarines. What Henke doesn't know, what none of the German submarine commanders operating in the Atlantic in early 1943 understand yet, is that the rules of underwater warfare have been rewritten by a British inventor who thought depth charges were inefficient and decided to build something better. The weapon is called Hedgehog. 240 projectiles arranged in a circle, fired forward from a mortar launcher while the attacking ship maintains sonar contact. Each projectile is armed by contact with a hard surface, not by depth or time delay. If you're listening through hydrophones from inside a submarine, Hedgehog gives you 3 seconds of warning, the splashes as projectiles enter the water. Then either silence, meaning the pattern missed and you might survive, or a series of sympathetic detonations as one contact triggers adjacent projectiles, creating a blast that no submarine pressure hull can withstand. Over the next 2 years, Hedgehog will sink more German submarines than any other single weapon system, transforming anti-submarine warfare from statistical probability into targeted execution. The psychological impact on U-boat crews will prove almost as devastating as the physical destruction. German submariners entered the war, believing their greatest advantage was time. Time to hear depth charges falling, count seconds until detonation, maneuver away from the blast pattern. Hedgehog eliminates time, eliminates warning, eliminates the margin between detection and death. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The path to Hedgehog begins not with naval officers or weapons designers, but with a civilian engineer who thought the Royal Navy was approaching anti-submarine warfare incorrectly. Lieutenant Commander Charles Goodave, recruited into the Admiralty's Department of Miscellaneous Weapons Development in 1939, possessed the kind of mind that questioned fundamental assumptions. Goodave had spent the 1930s teaching chemistry at University College London, studying reaction kinetics and thermodynamics. When war broke out, the Admiralty pulled him into military research, gambling that fresh perspectives might solve problems career naval officers had stopped questioning. The problem Goodave identified was simple. Depth charges were area weapons designed for an era when submarines could only be detected imprecisely. You estimated the target's position, dropped a pattern of charges set to various depths, and hoped the pressure waves cracked something vital. By 1941, Allied sonar had evolved significantly. Operators could track submarines with reasonable accuracy, maintaining contact for extended periods. But the weapons hadn't kept pace with detection capability. Destroyers still had to pass directly over a submarine's estimated position before dropping charges astern. This created a fundamental tactical problem. In the final seconds of an attack run, when the destroyer crossed above the submarine, sonar contact was lost. The submarine sat in a dead zone, directly beneath the attacking ship, where sound waves couldn't reach. Submarine commanders exploited this window ruthlessly. The moment sonar pinging stopped, indicating the destroyer was overhead, experienced captains would execute emergency maneuvers. Full rudder, change depth, alter speed. By the time depth charges detonated 7 or 8 seconds after hitting the water, the submarine had moved. The charges exploded where the target had been, not where it was. Hit probability hovered around 4% per attack run. Statistically, you needed to drop 25 depth charge patterns to achieve 1 submarine kill. Most U-boats escaped long before the 25th pattern could be delivered. Gudev recognized that the problem wasn't charge, explosive power, or detonation depth. German submarines in 1941 were being built with stronger pressure hulls, but even earlier boats could survive near misses if the charges exploded more than 20 feet away. The problem was firing geometry. Dropping weapons behind you meant losing target contact at the critical moment. What if, Gudev proposed in a 1941 memo, destroyers could fire forward, maintain sonar contact throughout the attack, eliminate the dead zone, give the submarine no warning and no time to maneuver? The concept wasn't entirely new. The Royal Navy had experimented with forward-throwing weapons during World War I, building massive mortars that lobbed 100-pound bombs off the bow. Those weapons proved too heavy, too slow to reload, and too inaccurate to be useful. By 1920, they'd been scrapped and forgotten. Gudev approached the problem from first principles, ignoring what hadn't worked 20 years earlier. His design requirements were specific. Fire a pattern of projectiles forward while maintaining full speed, at least 15 knots. Deliver enough explosive power to crack a submarine pressure hull. Cover an area large enough that minor targeting errors wouldn't cause complete misses. Detonate only on contact with a solid target, not at preset depth. That final requirement was crucial and controversial. Senior Admiralty officers argued that depth charges exploding at preset depths were reliable. You knew they'd detonate whether they hit anything or not. Contact-fused projectiles seemed less certain. What if the fusing mechanism failed? What if projectiles buried themselves in mud without exploding? Gudev's counterargument was mathematical. If a depth charge pattern has a 4% hit probability, 96% of your ordnance is wasted, exploding harmlessly in open water. A contact-fused weapon might have a lower per projectile hit probability, but it tells you immediately whether you hit. Silence means miss. Explosion means kill. The feedback is instant and actionable. By mid-1941, Gudev had convinced enough senior officers to fund prototype development. The project was assigned to the Admiralty's Directorate of Miscellaneous Weapons Development, a bureaucratic title that concealed some of the war's most innovative engineering. The team included Lieutenant Commander Stuart McIntyre, a career naval officer with gunnery experience, and a dozen civilian engineers and physicists pulled from universities and private industry. The weapon that emerged from their collaboration looked nothing like a conventional naval gun. Instead of a single large barrel, Hedgehog used 24 spigot mortars arranged in 4 rows of 6. Each mortar was a simple steel rod, called a spigot, protruding vertically from a welded steel frame. The projectiles themselves were 65-pound bombs shaped like teardrops, with a hollow tail that fit over the spigot. Inside each tail was a small propellant charge, essentially a shotgun shell scaled up. The firing sequence was elegant. An electrical impulse detonated the propellant charge inside the projectile's tail. The explosion drove the projectile upward off the spigot, while simultaneously pushing the spigot downward against a compressed spring. The entire launcher rocked backward about 5 degrees, absorbing recoil. When the last projectile cleared its spigot, springs returned the launcher to battery position. Reload time was approximately 3 minutes per full pattern. Each projectile carried 35 pounds of Torpex, a British explosive compound roughly 50% more powerful than TNT. The nose contained the contact fuse, a simple mechanical device that armed itself after the projectile travelled about 40 feet through air. Before that point, the fuse was inert, preventing accidental detonation if a projectile fell back onto the ship. Once armed, Any impact with resistance exceeding that of water would trigger detonation. The projectiles were designed to sink at a rate of approximately 23 feet per second after hitting the water. The launcher fired all 24 projectiles in under 3 seconds. The pattern they created in the water was roughly circular, about 140 feet in diameter. This coverage area was calculated based on sonar accuracy. If your range and bearing estimate was off by 70 feet in any direction, you'd still get projectiles near the target. The attack profile worked like this. Sonar operator maintains contact on the target submarine. Range closes to 700 yards, roughly a quarter mile. The attacking destroyer maintains course and speed, typically 15 to 18 knots. At calculated firing point, Hedgehog launches all 24 projectiles forward in a ballistic arc. Projectiles travel roughly 250 yards through air, hit the water in an elliptical pattern, and sink toward the submarine's estimated position. Time from launch to water impact is roughly 4 seconds. Time from water impact to reaching 100 feet depth is another 4 to 5 seconds. Total time from launcher firing to potential hit, under 10 seconds. If the submarine is where sonar said it was, and if the firing solution was accurate, at least one projectile will make direct contact with the pressure hull. That single contact detonation will trigger adjacent projectiles through sympathetic detonation, creating a cluster of explosions concentrated on the target rather than dispersed in a wide pattern. The blast effect is catastrophic. 35 pounds of Torpex detonating on contact with a pressure hull creates a penetration zone roughly 3 feet in diameter. The shockwave propagates through the submarine's internal structure, shattering equipment, rupturing pipes, and most critically, opening the pressure hull to the ocean. Water floods in at rates exceeding 200 gallons per second. Watertight doors help, but only if the crew has time to seal them. A direct Hedgehog hit typically gives crews less than 30 seconds before compartments flood completely. The first Hedgehog launchers were installed on Royal Navy corvettes and destroyers in late 1941. The weapon entered combat operations in January 1942. Initial results were mixed, not because of weapon deficiencies, but because crews were still learning optimal employment tactics. Early attacks were conducted at excessive range, reducing accuracy. Ships fired at targets that were maneuvering aggressively, making targeting solutions less reliable. Several launchers suffered mechanical problems, projectiles misfiring or failing to clear the spigots properly. But by mid-1942, operational experience was generating doctrinal refinements. Optimal firing range settled at 600 to 700 yards. Attacks worked best when the submarine was running straight and level, trying to quietly sneak away rather than conducting violent evasive maneuvers. Sonar operators learned to update firing solutions continuously right up to the launch moment, accounting for target movement. The feedback loop between Hedgehog attacks and crew training accelerated tactical evolution. Unlike depth charge attacks where you dropped patterns and hoped, Hedgehog gave immediate confirmation. No explosion meant you missed. Adjust estimate and attack again. Explosion meant kill. Report success and move to the next contact. This binary feedback transformed anti-submarine warfare from art into science. Crews could quantify their accuracy, identify which targeting methods worked, and refine techniques patrol by patrol. By late 1942, experienced Hedgehog teams were achieving hit rates approaching 25% per attack. That's 6 times better than depth charge attacks. The weapon's effectiveness showed in the statistics. Between January 1942 and May 1943, Hedgehog-equipped ships sank 47 confirmed U-boats. That's nearly half the Royal Navy's total submarine kills during that period. More significantly, Hedgehog attacks used far less ordnance. A single 24 projectile pattern weighed 1,560 pounds of total explosive. A standard depth charge pattern might drop 8 charges, totaling 3,200 pounds of explosive. Hedgehog delivered roughly half the explosive weight, but achieved 6 times the hit probability. For convoy escorts operating far from resupply, this efficiency mattered enormously. Ships could conduct more attacks per patrol before exhausting ammunition. The psychological dimension of Hedgehog warfare emerged gradually, revealed through interrogation reports of German submarine crews who survived sinkings. British intelligence officers interviewing prisoners of war began noting a pattern in late 1942. Submariners who'd survived Hedgehog attacks described the experience differently than depth-charge survivors. Depth-charge survivors talked about duration, the hours-long ordeal of repeated attack patterns, the gradually increasing fear as near misses crept closer. Hedgehog survivors talked about suddenness, the lack of warning, the terrifying realization that the weapon had already launched before they knew an attack was coming. One survivor, Oberleutnant Zursi Karl Heine from U-221, provided detailed testimony after his submarine was sunk by HMS Starling in March 1943. His account, declassified in 1978, captures the psychological shock. "We were running submerged at 120 meters, making 4 knots on electric motors. Silent running procedure, everything shut down except essential systems. The British destroyer had been tracking us for maybe 40 minutes, persistent but not aggressive. We thought we'd lose them eventually, slip beneath a thermal layer. Then we heard splashes overhead, many splashes very close together. The captain ordered an emergency dive. Before we reached 150 meters, the forward compartment exploded. I was in the control room. The blast threw me against the periscope housing. The boat tilted nose down, 45 degrees or more. Water was flooding forward. We couldn't close the forward hatch. The frame was bent from the explosion. The boat sank to 280 meters before internal pressure equalized and some buoyancy returned. By then, we had maybe 30 men still alive out of 52. We surfaced and abandoned the ship. The British picked us up. What I remember most is the speed, from the splashes to the explosion, maybe 5 seconds. No warning, no time to prepare, just sudden catastrophic damage. Heine's testimony wasn't isolated. Throughout 1943 and into 1944, captured U-boat crews described Hedgehog attacks using remarkably similar language: instantaneous, no warning, no chance to maneuver. The psychological impact rippled through the German submarine service faster than official casualty reports could travel. Survivors returned to Lorient, Saint-Nazaire, and Brest with stories that contradicted everything veteran submariners thought they understood about anti-submarine warfare. The German Naval Command, the Kriegsmarine, initially dismissed these reports as exaggeration or combat stress. Admiral Karl Dönitz, commanding the U-boat fleet, had built his tactical doctrine around the assumption that submarines possessed inherent advantages in underwater combat. Speed of sound in water gave sonar operators only rough bearing estimates. The dead zone beneath attacking destroyers provided crucial seconds for evasive maneuvers. Depth and darkness remained the submariner's best protection. Hedgehog undermined every assumption. By June 1943, German naval intelligence had compiled enough survivor testimony to recognize they were facing a genuinely new weapon system. Kriegsmarine analysts designated it Eagle in their reports, the German word for hedgehog, though initially they weren't certain whether this was one weapon or several different systems producing similar effects. The challenge for German intelligence was piecing together accurate technical details from traumatized survivors who'd experienced the weapon from inside a disintegrating submarine. Early German assessments overestimated Hedgehog's capabilities, while simultaneously underestimating its tactical significance. Some reports suggested the projectiles were rocket-propelled, traveling underwater at torpedo speeds. Others claimed the weapons were guided, actively homing on submarine hulls. The truth was simpler and more devastating. The projectiles were ballistic, unguided bombs that sank passively after water impact. What made them lethal wasn't sophisticated guidance systems, it was forward-firing geometry, contact fusing, and the elimination of warning time. Dönitz issued tactical guidance to submarine commanders in July 1943, attempting to counter the new threat. The directives focused on what little Kriegsmarine intelligence had confirmed. If you hear multiple rapid splashes directly overhead, assume Eagle attack, execute immediate emergency maneuvers. Full rudder, change depth immediately, crash, dive if already submerged, surface and run if caught shallow. The guidance was sound in theory but nearly useless in practice. The time window between hearing splashes and potential impact was under 5 seconds at typical combat depths. Emergency maneuvers took longer than that to generate meaningful position changes. A submarine at 100 meters traveling 4 knots needed at least 20 seconds to alter course by 45 degrees or change depth by 50 feet. Hedgehog projectiles reached 100 meters in roughly 5 seconds after water impact. The math was brutal and simple. You couldn't hear the attack and evade it. You could only hope the firing solution was inaccurate. Throughout the second half of 1943, Hedgehog's operational effectiveness continued improving. The weapon was installed on an expanding number of Allied escort vessels. British corvettes and destroyers received priority, but American destroyer escorts were also being fitted with the system under reverse lend-lease arrangements. Manufacturing capacity increased as British and American factories ramped up production. By January 1944, more than 200 Allied ships carried Hedgehog launchers. The weapon's success generated demand for improved versions. The Mark X Hedgehog, introduced in mid-1943, incorporated a more reliable contact fuse and slightly increased explosive charge. The Mark XI, deployed in 1944, featured improved launcher construction that reduced mechanical failures. But the fundamental design remained Charles Goodev's original concept: forward-firing spigot mortars, contact-fused projectiles, binary feedback confirming hits or misses. Statistical analysis of Hedgehog effectiveness tells the story clearly. In 1942, Hedgehog-equipped ships achieved approximately 15% kill probability per attack. By 1943, that number reached 25%. In 1944, experienced crews pushed effectiveness above 30%. Compare that to depth charge attacks, which remained around 5 to 7% kill probability throughout the war. A single Hedgehog attack had roughly the same chance of sinking a submarine as 5 depth charge attacks, while using 1/3 the explosive tonnage. The efficiency translated directly into strategic impact. The Battle of the Atlantic, the sustained German submarine campaign against Allied shipping, reached its crisis point in early 1943. U-boats were sinking merchant vessels faster than Allied shipyards could replace them. Dönitz had over 400 operational submarines, and he was deploying them in coordinated wolfpack tactics that overwhelmed convoy escorts. Then, the curve bent. Allied merchant shipping losses dropped sharply in May 1943. Multiple factors contributed, including improved air coverage from long-range patrol aircraft, better convoy routing based on ultra-intelligence decrypts, and increased numbers of escort vessels. But Hedgehog played a disproportionate role. Ships equipped with the weapon were sinking submarines at rates that fundamentally changed the tactical equation. German submarine losses climbed from roughly 10 per month in early 1943 to 25 per month by mid-year. The Kriegsmarine couldn't sustain those loss rates. Training new crews took 9 months. Building new submarines took 12 to 18 months. Every experienced crew killed in a Hedgehog attack represented irreplaceable institutional knowledge. The psychological toll compounded the tactical losses. Survivor testimony from multiple U-boats described crews becoming increasingly fatalistic about their odds. When experienced submariners start believing they can't survive detection, operational effectiveness collapses. One particularly revealing document, a letter from Captain Lieutenant Ernst Bauer to his wife, written in October 1943 and intercepted by British postal censors, captures the shifting mentality among German submarine commanders. Bauer had survived 2 war patrols and was preparing for his 3rd. The letter, declassified in 1992, is remarkably candid. The British have changed something fundamental about their attacks. We used to have time, even when they found us. Time to go deeper, alter course, rig for silent running, and wait them out. Now, when they attack, there is no time. You hear splashes, and then either you survive because they missed, or you don't survive because they didn't miss. There is nothing in between. No gradual escalation, no pattern you can analyze and counter. just sudden violence or silence. The men feel it. They know that skill and experience matter less than they used to. We are becoming targets in a shooting gallery, hoping the shooter's aim is off. Bowers' submarine, U-341, was sunk by HMS Kite using Hedgehog in February 1944. There were no survivors. The technological response from Germany came too late and achieved too little. Kriegsmarine engineers developed acoustic countermeasures, devices towed behind submarines that generated noise intended to confuse sonar. These might have been effective against depth charge attacks, where deflecting the destroyer's approach by even a few degrees could mean the difference between near miss and survival. Against Hedgehog's wide pattern coverage, small deflections didn't matter. If you were in the target zone, being 40 feet off the estimated center point still put you inside the lethal pattern. German submarine designers also explored solutions. The Type XXI U-boat, introduced in limited numbers in late 1944, incorporated significantly increased diving speed and maximum depth capability. The Type XXI could crash dive to operational depth in under 20 seconds and operate safely at depths exceeding 800 feet. In theory, this provided the speed and depth margin to possibly evade Hedgehog attacks. In practice, only a handful of Type XXI boats entered operational service before the war ended, and none encountered Hedgehog in combat conditions that would have tested the new capabilities. The weapon's success created unexpected challenges for Allied navies. Hedgehog's high kill probability meant that ships scoring hits often had no opportunity to recover intelligence materials or capture crew for interrogation. Depth charge attacks, with their lower lethality, frequently forced submarines to surface where crews could abandon ship before sinking. Those surfaced submarines provided chances to board and recover codebooks, cipher machines, and technical documentation. Hedgehog killed too cleanly. This tension between tactical effectiveness and intelligence gathering became particularly acute in 1943, when Allied intelligence desperately wanted to capture newer German cipher equipment. Several Hedgehog-equipped ships received orders to attempt depth charge attacks first, switching to Hedgehog only if the submarine showed no signs of surfacing. The guidance was controversial among ship captains, who reasonably asked why they should use less effective weapons to protect intelligence priorities. The compromise was never fully resolved, though by late 1944 the point was moot, as Allied cryptographic capabilities had advanced enough that captured materials offered diminishing returns. Beyond the Atlantic, Hedgehog saw service in other theatres with varying effectiveness. The weapon equipped Royal Navy and U.S. Navy ships operating in the Mediterranean, where it proved effective against German and Italian submarines. In the Pacific theatre, Hedgehog was installed on destroyer escorts assigned to anti-submarine patrol, though Japanese submarine doctrine differed significantly from German tactics. Japanese submarines generally operated independently rather than in coordinated wolf packs, and they prioritized fleet operations over commerce raiding. The weapon still achieved notable successes. USS England, a destroyer escort equipped with Hedgehog, sank 6 Japanese submarines in 12 days during May 1944, a record for any single ship in any navy during the war. England's success demonstrated that Hedgehog effectiveness wasn't limited to Atlantic conditions or German submarines. The fundamental tactical advantages, forward-firing geometry and contact fusing, applied universally. The post-war assessment of Hedgehog's contribution to Allied victory took years to compile. Final statistics credited the weapon with sinking or contributing to the sinking of approximately 80 German U-boats between January 1942 and May 1945. That represents roughly 10% of total German submarine losses during the war. The number seems modest until you consider that Hedgehog-equipped ships represented a minority of Allied anti-submarine vessels for most of the war. Ships with Hedgehog achieved kill rates 4 to 6 times higher than ships using only depth charges. More significantly, Hedgehog's success validated forward-firing anti-submarine weapons as a fundamental tactical approach. The principle, maintain sonar contact throughout the attack by firing ahead rather than dropping weapons astern, became foundational doctrine for post-war anti-submarine warfare. Modern naval forces exclusively use forward-firing weapons, rockets, torpedoes, and guided missiles, all building on concepts Charles Gudev articulated in 1941. The weapon itself remained in service for decades after World War II. Royal Navy ships carried Hedgehog launchers into the 1960s. The U.S. Navy continued using the weapon through the Korean War and beyond, eventually replacing it with more sophisticated systems like ASROC, which fired homing torpedoes rather than contact-fused bombs. But the fundamental tactical principle remained unchanged. Fire forward, maintain contact, eliminate warning time. For the German submariners who faced Hedgehog in combat, the weapon represented a fundamental shift in the nature of underwater warfare. The advantage they'd relied on, time to react after detection, was eliminated. The psychological security that came from hearing depth charges fall and knowing you had seconds to maneuver was replaced by sudden, catastrophic violence with no warning. Survival became a matter of whether the attacking ship's firing solution was accurate, not whether your crew could outthink and outmaneuver the enemy. That shift, from active defense to passive hope, broke something essential in the German submarine service's morale. When experienced crews start believing their skills can't protect them, when survival feels random rather than earned, operational effectiveness deteriorates rapidly. Hedgehog didn't just sink U-boats. It sank the confidence and psychological resilience that made German submarine crews effective in the first place. The weapon's legacy extends beyond tactical success. Hedgehog demonstrated that challenging fundamental assumptions about established warfare methods could yield revolutionary improvements. Charles Gudev wasn't a career naval officer bound by decades of institutional doctrine. He was a civilian scientist who looked at anti-submarine warfare and asked whether the standard approach made sense. That outsider perspective, combined with engineering expertise and support from forward-thinking Admiralty officers, produced a weapon that changed the course of the Battle of the Atlantic. In the final accounting, Hedgehog stands as one of World War II's most effective weapons systems, not because of technological sophistication, but because of tactical insight. The projectiles were simple bombs. The launcher was an unsophisticated mortar system. What made Hedgehog revolutionary was understanding that forward-firing geometry and contact fusing could eliminate the fundamental advantages submarines relied on for survival. That insight, translated into operational hardware and deployed at scale, helped turn the tide in the war's longest continuous campaign. For Werner Henke, commanding U-515 that March day in 1943, and for thousands of other German submariners who heard splashes overhead in the final seconds before their submarines were destroyed, Hedgehog represented something unprecedented in naval warfare, a weapon that gave no second chances, no time to react, no opportunity to employ hard-earned skills and experience. Just sudden, catastrophic violence, and then silence. The personal stories emerging from Hedgehog attacks reveal dimensions of naval warfare that statistics cannot capture. Consider the crew of U-432, attacked by HMS Hesperus in March 1944 approximately 300 miles west of Ireland. The submarine was running submerged at 90 meters, conducting a slow creep away from a convoy they'd been shadowing for 6 hours. The British destroyer had detected them 90-10 minutes earlier and maintained intermittent sonar contact. Korvettenkapitän Hermann Eckart, commanding U-432, had 22 months of combat experience. He'd survived 11 war patrols, sunk 14 Allied merchant vessels totaling 87,000 tons, and earned the Knight's Cross for his successes in the North Atlantic. His tactical instincts had kept him alive through encounters with dozens of escort vessels. Those instincts told him Hesperus was setting up for a depth charge run, positioning to pass overhead and drop charges astern. Eckart ordered his submarine to turn hard to starboard, angling away from the destroyer's projected path. Standard evasion, executed hundreds of times in training and dozens of times in combat. The maneuver would put U-432 outside the depth charge pattern's kill radius. Then he heard the splashes. 24 distinct impacts on the surface, grouped tightly, directly ahead of his submarine's new course. His mind processed the implications in the 2 seconds before the first projectile reached his depth. Not depth charges. The new weapon, Hedgehog. And he turned directly into the pattern instead of away from it. The first projectile struck U-432's starboard bow at a shallow angle, penetrating the outer hull but not the pressure hull before detonating. The explosion was still catastrophic. The blast wave propagated through the ballast tanks and into the forward torpedo room. 3 torpedoes stored in their tubes detonated sympathetically. The combined explosion, roughly 800 pounds of high explosive, tore the entire bow section away from the submarine. Water flooded through the severed forward compartment at a rate that made watertight doors irrelevant. The submarine's bow pointed straight down. Eckhart ordered an emergency surface, blowing all ballast tanks simultaneously, but the loss of the entire bow section meant the submarine had no buoyancy forward. U-432 corkscrewed toward the bottom, stern first, rotating slowly. The pressure hull collapsed at 412 meters. 14 men in the after torpedo room survived the initial attack and the descent. They drowned when the hull failed. Hesperus recorded the attack in its log with clinical precision. 1,434 hours. Hedgehog attack on firm contact bearing 270, range 600 yards. 4 explosions were heard. Heavy underwater disturbance observed on the surface. No survivors sighted. Assessed kill. British intelligence interviewed Hesperus's captain, Commander Donald McIntyre, 3 weeks later, as part of ongoing assessment of Hedgehog tactics. McIntyre's testimony, preserved in Admiralty records, provides insight into how attacking crews experience these engagements. The moment you hear the explosions, you know. With depth charges, you drop the pattern and wait, wondering if you got close enough. Sometimes you see oil or debris later, sometimes nothing. With Hedgehog, the feedback is immediate. Explosions mean direct hit. Silence means miss. There's no ambiguity, McIntyre continued. What surprised me was how quickly the submarine went down after a hit. Depth charges might damage a boat badly enough that it surfaces or breaks up slowly. Hedgehog hits seem to cause immediate catastrophic failure. The target just vanishes. One moment you have a solid contact, next moment there's debris rising, and then nothing. I think the contact fusing means the explosions happen right against the hull rather than nearby. The violence is more concentrated. This concentration of explosive force against the pressure hull created survival conditions that differed dramatically from depth charge attacks. Analysis of U-boat casualties from 1943 and 1944 shows striking patterns. Submarines sunk by depth charges had survivor rates around 18%. Submarines sunk by Hedgehog had survivor rates around 4%. The difference reflects attack physics and available escape time. A depth charge detonating 25 feet from a submarine might crack welds, rupture pipes, or disable machinery without immediately flooding the entire vessel. Crews potentially had minutes to attempt emergency surfacing or evacuate through escape hatches. A Hedgehog projectile detonating on contact with the pressure hull created a penetration that flooded compartments in seconds. The shockwave propagated through the submarine's structure more efficiently, causing secondary damage throughout the vessel. Crews had seconds, not minutes. The few survivors of Hedgehog attacks who made it to the surface faced their own challenges. U-boats typically operated hundreds of miles from land in the North Atlantic. Water temperatures ranged from 35 to 50 degrees Fahrenheit depending on season and location. Hypothermia became the immediate threat. Without life rafts or survival suits, most men who reached the surface after their submarines sank lasted less than 30 minutes in the water. Allied doctrine on rescuing submarine survivors evolved as the war progressed. Early in the conflict, destroyer captains faced difficult decisions about stopping to rescue survivors versus maintaining convoy protection. A stationary destroyer became vulnerable to other submarines potentially operating nearby. By 1943, standard practice called for one escort to remain with the convoy, while another rescued survivors if tactical situation permitted. But Hedgehog attacks often provided no survivors to rescue. The weapon's lethality meant crews either escaped before the submarine sank, which was rare, or went down with the vessel. British and American destroyer logs from 1943 and 44 contain numerous entries documenting Hedgehog attacks where extensive surface searches found no survivors and minimal debris. This absence of survivors had intelligence consequences beyond the previously ATA mentioned challenge of recovering code books and cipher equipment. Prisoner interrogation provided crucial information about German submarine tactics, crew morale, technical capabilities, and operational orders. Each submarine crew represented a potential intelligence source. The prisoner of war camps at Grisdale Hall and later at Fort Hunt processed hundreds of German submariners, extracting information that shaped Allied anti-submarine strategy. Hedgehog's effectiveness reduced this intelligence flow. Fewer survivors meant fewer interrogations, less insight into evolving German tactics. Allied intelligence officers found themselves in the paradoxical position of wanting the anti-submarine weapon to be slightly less lethal to preserve intelligence collection opportunities. The tension was never fully resolved. Tactical commanders prioritized sinking submarines. Intelligence officers wanted prisoners. Hedgehog delivered the former at the expense of the latter. The weapon's psychological impact on Allied crews was complex and often overlooked in post-war assessments. Destroyer and corvette crews spent weeks or months on convoy escort duty, encountering submarines intermittently. Most attacks, whether using depth charges or Hedgehog, resulted in misses. Contact would be lost, the submarine would escape, and the escort would rejoin the convoy. Successful attacks, especially those producing confirmed kills, were rare events in any individual ship's experience. For crews firing Hedgehog, the binary feedback created unique psychological dynamics. Silence after launching meant you missed completely. No maybes, no near misses, to debate in the wardroom later. You either got nothing, or you got explosions that meant you just killed 50 men. There was no middle ground, no ambiguous outcome where you damaged the target and forced it to flee. This clarity was tactically valuable, but psychologically stark. Lieutenant James Morrison, serving aboard the corvette HMS Sunflower, kept a personal diary throughout his service from 1942 to 1945. His entries, donated to the Imperial War Museum in 1989, provide rare insight into how attacking crews processed Hedgehog kills. One entry from May 1944 reads, "3rd, Hedgehog attacked this patrol. First 2 were silence, no explosions, target escaped. Today we got the bastard. 4 detonations, big ones, debris coming up including fuel oil and pieces of what might have been deck plating. Captain ordered a search pattern, but we found no survivors. Chief says at least 50 men were on that boat, all dead in maybe 10 seconds from our attack to their pressure hull failing. I know they'd have done the same to our convoy given the chance. I know we're saving merchant seamen by killing U-boat crews. Still feels different than I expected. Not bad exactly. Just final. Absolute." Morrison survived the war, and later wrote that the crews celebrated confirmed Hedgehog kills the same way they celebrated any submarine sinking, but the celebrations felt different. With depth charge kills, especially those that forced submarines to surface, there was often a sense of having outfought the enemy in a battle that both sides survived, even if one side lost. Hedgehog kills felt more like executions. Target detected, weapon fired, target eliminated. The enemy never had a chance to fight back or escape. This psychological dimension extended to how different navies viewed Hedgehog adoption and employment. The Royal Navy, fighting an existential battle against submarine warfare that threatened Britain's survival, embraced the weapon enthusiastically. British tactical doctrine emphasized aggressive prosecution of contacts and maximum lethality. Hedgehog fit that doctrine perfectly. The U.S. Navy's relationship with Hedgehog was more complex. American destroyer doctrine emphasized versatility and multi-mission capability. Hedgehog installations required dedicating significant deck space to a weapon useful only for anti-submarine warfare. American destroyer escorts, built specifically for convoy protection, received Hedgehog installations as standard equipment, but fleet destroyers, expected to perform anti-aircraft, surface combat, and anti-submarine roles, often carried depth charges exclusively until 1944, when operational experience demonstrated Hedgehog's overwhelming effectiveness. USS England's success in the Pacific during May 1944, sinking 6 Japanese submarines in 12 days exclusively with Hedgehog attacks, converted many skeptical American naval officers. England's captain, Lieutenant Commander Walton Pendleton, developed Hedgehog tactics that became standard doctrine for Pacific destroyer escorts. His after-action reports emphasized patience and precise targeting over aggressive rapid attacks. Pendleton's approach involved maintaining sonar contact for extended periods, sometimes over an hour, while plotting the target submarine's course and speed with maximum accuracy. Only when he had high confidence in his firing solution would he close to attack range and launch Hedgehog. This patience paid off with 6 kills from 9 attacks, a 67% success rate that far exceeded Atlantic averages. Pendleton's reports argued that Hedgehog's contact fusing rewarded accuracy over volume of fire. 1 perfectly aimed pattern was worth 5 hasty attacks. The tactical evolution of Hedgehog employment continued throughout 1944 and into 1945. Crews learned that attacking submarines while they were conducting evasive maneuvers reduced hit probability significantly. The optimal target was a submarine running straight and level, either unaware of detection or attempting a quiet escape rather than aggressive evasion. This insight shaped hunter-killer tactics, where escort groups would maintain passive sonar contact on submarines for extended periods without attacking, waiting for the target to settle into predictable movement before striking. German submarine crews gradually adapted to this new tactical environment, though their options were limited. By late 1944, experienced U-boat captains understood that being detected by an escort group meant facing Hedgehog attack. The standard evasion was to go deep immediately, deeper than the submarine's rated maximum depth, gambling that stress on the pressure hull was preferable to remaining at depths where Hedgehog was most effective. Type 7 U-boats had official maximum operating depths around 250 meters, though many boats could safely reach 300 meters or slightly deeper depending on hull condition and construction quality. Diving below 300 meters risked catastrophic hull failure, but might put the submarine beneath the depth where Hedgehog projectiles remained effective. The projectiles sank at 23 feet per second, approximately 7 meters per second. Reaching 400 meters took roughly 60 seconds after water impact. But sonar accuracy degraded significantly at extreme depths, and escorts often lost contact when submarines dove deep. This created a deadly gamble for U-boat crews. Stay shallow and face Hedgehog attack with limited evasion options. Dive deep and potentially exceed hull limits while gambling that the escort would lose contact. Neither option guaranteed survival. The fact that German submariners increasingly chose the deep dive option, risking certain death from hull collapse to avoid possible death from Hedgehog, speaks to how they perceived the weapon's lethality. Post-war analysis attempted to quantify Hedgehog's strategic contribution to Allied victory in the Atlantic. The consensus among naval historians is that the weapon was one of several critical factors that turned the Battle of the Atlantic in May 1943. Ultra-intelligence, providing decrypted German naval communications, allowed convoys to route around known submarine concentrations. Long-range air patrol, particularly B-24 Liberators equipped with radar and depth charges, closed the mid-Atlantic air gap where submarines had previously operated with impunity. Increased numbers of escort vessels, built by American and British shipyards at accelerating rates, meant more ships per convoy and more aggressive hunter-killer groups. Within that multi-factor equation, Hedgehog's contribution was force multiplication. Ships equipped with the weapon achieved kill rates that effectively made each Hedgehog-equipped escort worth 4 or 5 depth charge, only escorts in terms of submarine sinking capability. This efficiency was crucial given the persistent shortage of escort vessels relative to the number of convoys requiring protection. A small number of highly effective ships could protect more convoys than a large number of marginally effective ships. The weapon also imposed psychological costs on German submarine crews that compounded tactical losses. Morale degradation within the U-boat service accelerated after Hedgehog entered widespread use. Survivor testimony consistently describes the weapon as particularly demoralizing because it eliminated the sense of agency that allowed submarine crews to function under extreme stress. Depth charge attacks were terrifying but interactive. Skilled crews could influence outcomes through tactical decisions. Hedgehog attacks removed that element. You either were where the pattern landed, or you weren't. Individual skill mattered less. When elite crews start believing that survival depends more on luck than competence, recruitment and retention suffer. The German submarine service experienced both. Volunteers declined as word spread about casualty rates and new weapon systems. Veteran crews, those who'd survived multiple patrols and possessed irreplaceable experience, increasingly chose non-combat assignments when opportunities arose. The Kriegsmarine's pool of experienced submariners shrank faster than training programs could replace them. By early 1945, many U-boats were sailing with crews where 40% or more had never completed a combat patrol. These inexperienced crews made tactical errors that veteran crews would have avoided, compounding the effectiveness of weapons like Hedgehog. A vicious cycle developed. New weapons increased casualties among experienced crews. Loss of experience decreased tactical competence. Decreased competence increased vulnerability to Allied weapons. The cycle accelerated German submarine force degradation until, by war's end, U-boats represented more danger to their own crews than to Allied shipping. Thanks for watching this deep dive into one of World War II's most innovative and devastating weapons. If you found this content valuable, consider subscribing and leaving a comment about which aspects of naval warfare history you'd like us to explore next. Until next time, remember that sometimes the most revolutionary advances come not from building something more complex, but from rethinking fundamental assumptions about how warfare works. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.